Have you ever looked up at the night sky? Have you ever felt small beneath that vast, dark blanket? Tiny points of light, what are they? A sun, a star, perhaps with its own family of planets. Our universe, endless mystery and breathtaking beauty. A story still being written, a puzzle with pieces scattered across billions of light years. We're just beginning to read its first pages, finding the first clues, more strange, more wonderful, more unbelievable. The cosmos is not empty space, a grand theater of creation, destruction, impossible worlds, cosmic miracles, not science fiction, real places, confirmed by our telescopes and calculations. Journey with me, venture into the unknown, and marvel at realities hiding in the depths of space. Imagine a world not too far from our own, cosmically speaking, just 63 light-years away in the constellation Vulpecula. From a distance it's a vision of tranquility, a beautiful deep blue planet, reminiscent of our own precious Earth. It looks like a peaceful marble floating in the silent expanse of space, a serene jewel against the velvet black. But this serene appearance is a grand illusion. Looks can be deceiving, and on this world, they are deadly. This is exoplanet HD 1897-33b. It belongs to a class of planets known as hot Jupiters, gas giants that orbit perilously close to their parent stars. It's a colossal world, about 13% more massive than our own Jupiter, completing a full orbit in just 2.2 Earth days. Its stunning cobalt blue color isn't the reflection of vast, life-giving oceans. Instead, it's a warning sign. The hue comes from an atmosphere laced with tiny particles of silicate, the very same mineral that makes up sand and glass on Earth. These particles scatter blue light, creating a beautiful facade for a truly hellish environment. This world is a place of extreme, unrelenting violence. Forget the worst hurricane on Earth, it would be a gentle breeze here. The winds on HD 1897-33b are ferocious, screaming across the planet at over 5,400 miles per hour. That's more than 7 times the speed of sound, a perpetual supersonic gale. This atmospheric chaos is driven by unimaginable heat. On its permanent day side, the temperature soars to over 1,800 degrees Fahrenheit, hot enough to melt lead. This intense heat doesn't just warm the silicate particles, it vaporizes them, turning them into a gaseous form of glass. You see, HD 1897-33b is tidally locked, just as our moon is to Earth. One side is trapped in an eternal day, constantly scorched by its star, while the other faces the endless cold of space. This creates a colossal temperature difference that fuels the planet's monstrous winds. These supersonic gales sweep the vaporized silicate from the scorching day side to the cooler night side. And as this glass vapor travels, it cools and condenses, not into gentle raindrops, but into droplets of molten glass. Then it begins to rain. But this isn't rain as we know it. It's a storm of glass shards, whipped sideways by the hypersonic winds, flying through the atmosphere like a blizzard of microscopic bullets. A world of sideways, razor-sharp rain. From afar, a beautiful blue dot. Up close, a nightmare of fire and flying glass. HD 1897-33b is a breathtaking cycle of cosmic horror and sublime beauty. It serves as a powerful reminder that the universe is filled with wonders that defy our imagination, and that beauty can often conceal the most extreme and terrifying realities. It makes you wonder, what other impossible worlds are waiting to be discovered? What is the most valuable thing you can think of? Gold? Platinum? What if I told you there is a planet made of something even more precious? A planet made of diamond. This is not a fantasy. This is 55 Cancri E, a super-Earth, just 40 light-years away, about twice Earth's size but 8 times more massive. Perhaps a third of its mass could be pure, solid diamond. The answer is in its chemistry, a carbon-rich star. Planets inherit their star's ingredients. Unlike Earth's silicates, this world is carbon-rich, graphite, other carbon compounds, and vast mountains of diamond beneath. The surface may reach 4,000 degrees Fahrenheit, its sky a hazy yellow. Imagine standing where the ground beneath your feet is the most sought-after gemstone on Earth. The discovery opens a new category, carbon planets, among water worlds and gas giants. The universe has a flair for creating the extraordinary. How can a world be searingly hot, hot enough to melt lead, and yet be frozen completely solid? It's a question that seems to break the fundamental laws of nature. It sounds like a cosmic riddle, a paradox that should be impossible. But in the deep expanse of space, such an extraordinary world does exist. Its name is Gliese 436b, a hot Neptune orbiting a dim red dwarf star. Roughly the size of our own Neptune, it's locked in a blisteringly fast orbit, whipping around its star in just 2.5 Earth days. This extreme proximity is the source of its impossible nature. Its atmosphere is scorched to an incredible 800 degrees Fahrenheit, a temperature where water should only exist as steam. And yet, based on its mass and density, scientists are confident this planet is composed primarily of solid ice. The solution lies in a bizarre state of matter known as hot ice. On Earth we only know one kind of ice, but under immense pressure water can freeze into different structures. The secret is the planet's immense gravity, which crushes the water molecules with a relentless force. This pressure is so great it physically prevents them from boiling, no matter how hot it gets. Instead, they are squeezed into a dense, crystalline lattice, remaining solid. It is a planet of burning, compressed ice. But the star's intense radiation still takes its toll. It relentlessly boils away the planet's outer hydrogen atmosphere. This escaping gas forms a colossal cloud, streaming behind the planet for millions of miles, like the tail of a magnificent comet. Every second, Gliese 436b loses about 1,000 tons of its mass, a world slowly evaporating into the void. It is a world trapped in an eternal battle, its own immense gravity fighting to hold it together against the searing power of its parent star. Gliese 436b is a profound reminder that the universe doesn't conform to our simple, earthbound rules. Here, matter behaves in ways far stranger than fiction, proving that the cosmos is filled with impossible wonders, where fire and ice can exist as one, a burning jewel set among the stars. Most planets we know are part of a family, but what if a planet had no sun, cast out from its home, destined to wander the darkness? Such worlds exist. One is PSO J318.5-22, a gas giant about 6 times Jupiter, drifting by itself. We find them by their faint heat, or by chance, when they magnify a distant star's light. There could be billions, perhaps trillions of these lonely wanderers in our galaxy. Our universe is about 13.8 billion years old, an ultimate age limit. Then came HD 140283, the Methuselah star. Early calculations suggested it was older than the universe. Refined measurements put it at about 14.27 billion years, with large error bars, no longer a paradox. It is incredibly ancient, population 2, made almost entirely of hydrogen and helium, born from nearly pristine gas, a fossil from the dawn, linking us to the universe's first light, a witness to the birth of galaxies, the lives and deaths of countless stars, and the grand evolution of the cosmos. In myths, vampires steal life for a twisted immortality. In the cosmos, some stars do the same. In close binary systems, as one star ages into a red giant, its outer layers spill past a gravitational boundary. This material is siphoned by its smaller companion. Rejuvenated by this stolen fuel, the star spins faster and burns with a brilliant, youthful blue light. These are blue stragglers, a violent, beautiful dance of gravitational theft and stellar rebirth. Deep in our Milky Way and the Eagle Nebula stand the pillars of creation, not stone but colossal columns of cool gas and dust stretching for light years. Within their shadowy folds, gravity creates dense knots, hiding newborn stars as they slowly ignite. But stars recently born nearby now unleash torrents of radiation. This fierce stellar wind blasts away at the pillars, sculpting and eroding them. It's a cosmic race, creation versus destruction. Even if the pillars vanish, their stars remain, a shining testament to our own cosmic origins. And then, profound emptiness, the Eridanus supervoid, a staggering chasm nearly 1 billion light-years across, mysteriously devoid of galaxies. Its existence is imprinted on the oldest light in the universe. As this ancient light traverses the void, it loses a tiny amount of energy, leaving a cold spot on the map of the Big Bang's afterglow. But the supervoid is far larger and colder than our models predict. Is it a rare fluke or a sign of new physics? It remains one of astronomy's most significant puzzles. From planets of diamond to glass and burning ice to lonely wanderers and stellar nurseries, each wonder is a clue. They are expressions of the fundamental laws that govern everything from the smallest atom to the largest supervoid. These laws connect us to the cosmos in the most intimate way. We are made of stardust, forged in the hearts of stars, like those emerging from the pillars. We are children of the cosmos, looking out from our small world with minds capable of comprehending this vastness. The story of the universe is still being written, and we are here to read its next chapter.